Hey, how's it going? Okay, so today we're looking at some molarity calculations for Chem 1. Here we go. So don't forget that molarity is concentration. We use molarity when we're trying to answer the question, how strong is the solution? Or, for instance, how much dissolved stuff really is present in the space that we have, maybe in a beaker or an Erlenmeyer. Um, Remember, as I always say in class, big M is moles over liters, and we're going to actually use that as a conversion factor for our calculations today. So I'd recommend grabbing a pen and pencil or a tablet, something to write on, and working these through. You can pause them and then wait for me to work it out after you've finished yours. So here we go. First question. Find the concentration if moles of NaCl are dissolved to make a 1.5 liter solution. All right, so your first step will be you need to figure out what you need. So you're trying to figure out concentration. So as we said, concentration is big M. We know that big M is moles over liters. So we can go ahead and plug in our values. The moles that we have are 3 mole of NaCl, and the total volume it says is 1.5 liters. So if we do 3 divided by 1.5, that's going to give us a concentration of 2. The unit will be moles and liters because those don't cancel, so we'll leave that as big M. So our final concentration is 2 molar NaCl. Okay, next. If we look here, we're going to find the concentration if 54 grams of sodium chloride are dissolved to make a 2.75 liter solution. Okay, so we know that we're finding again, what is big M? We know that that is moles over liters. If we look, we've got liters, and this, 54 grams, is something that will give us moles. Okay, so your first step will be to take 54 grams, toss that over 1, and we're going to multiply by the molar mass of NaCl. NaCl total is going to be 58.5 grams per mole. Okay, so I'm going to show this all actually as one step, just so we get the hang of doing that. If we look, I'm going to take 54 grams, divide that by 58.5 grams over 1 mole. That will cancel grams out for us, fortunately. And now I'm going to show the second step in black. So if you wanted, you could write an equal sign here, figure out moles, and then go forward. I know that I want our next unit to be liters so that we can have moles divided by liters at the end and nothing else cancels. Okay. So if we look, we have to take whatever our liter value is. So I'm going to put that in the denominator because I know that I want my answer to be moles divided by liters. And then you can just leave the top blank and have 1 divided by that. Okay? That should make all your stuff work out. Remember, I'm going to label it underneath. That could be your first step, just using this part. And then your second step is dividing that answer by 2.75. I'm showing it all as 1. And here we go. So that equals 0.34 molar. All right, and that will be our final answer. That is our concentration of NaCl that would result from that solution. Okay, next. Now instead of making the concentration, you're going to actually use the concentration as a conversion factor to convert between volume and moles. Okay, so we're going from volume to moles. Okay, so I'm going to first change my volume to liters. The nice thing about milliliters, you can just move the decimal point over 3 times. That's the same as dividing by 1,000. And I'll put 1.7 liters over 1, and I'm going to multiply by this conversion factor. As I say in class, always take the conversion factor 2.5. And whenever you see big M, you change that to moles divided by 1 liter, right? So if I give you a concentration, that's when you take big M and make it moles divided by 1 liter. I'm going to look at this. I know that I want liters to cancel, so I need to flip this conversion factor, or sorry, I need to leave it the same so that liters will cancel. If I flipped it, it would not cancel. So I'm going to cancel out liters. I get 1.7 times 2.5, which is 4.25 mole. And that's how many mole of HCl that you would have in that solution. Okay. Next, find the grams of NaOH necessary to make 350 milliliters of a 3.2 molar NaOH. Okay, so if we look, we're going to go ahead and change milliliters immediately because we don't want to work with those. We want to work with liters. So I know that that is 0.35 liters. I will put that over 1. And I'm trying to get grams. In order to get grams, if I have a volume to start, I need to get to moles. So I'm going to multiply by my conversion factor. I know that this is the conversion factor, and that means 3.2 moles over 1 liter, right? That would be step 1, and I'll label that with a 1 underneath. You could write equals. That will cancel out your liters, and then you would have your answer in moles to then convert to grams. Instead of showing that as 2 steps, I'm again going to show it as all 1. So I'm going to take the molar mass of NaOH, and I'm going to multiply that by that. So if we look, NaOH is 40 grams for every 1 mole, and I've set it up like this so that moles will cancel. That's going to leave us with grams, and our final answer will be 44.8 grams of NaOH. All right? And in red would be the second equation if you wanted to have 2 separate equations. Okay. Let's find the volume of a solution if 150 grams are dissolved to make 0.75 molar nitric acid. Okay, so we're working with pH soon. Nitric acid will be an acid that you need to become familiar with. So let's identify what we have to start. Okay, they want to know volume. Okay, so we want to find volume, right? And we know that this is 0.75 moles over 1 liter. I know that I can get moles from grams, so I'm going to use these 2 things to cancel out moles and to get liters, because this conversion factor right here will let me change between moles and liters. Okay, so let's start. I'm going to take my 150 grams, put that over 1, and go ahead and convert that to moles. So I want to be moles, I put that in the numerator. And then I need to divide by the molar mass of HNO3, which happens to be 63 grams. I'm going to again show this all as one problem. So at this point, you could stop and put an equal sign. That is the first step. And then I'll change colors for you. Okay. I'm going to take my conversion factor and just go ahead and place it right here. This would be the second step of the problem. I'm going to actually have to flip it over, though, because I want moles to cancel, and I want liters to be my final answer. So if I go ahead and do 150 divided by 63 divided by 0.75, that's going to give me 3.3 liters as the final volume of my solution. All right, so here's our last problem. It's probably one of the harder ones. Find the number of sodium atoms in a 500 milliliter solution of 0.5 molar sodium carbonate. Okay, so let's identify right here. You're dealing with a molecule. For every 1 molecule, you're going to have 2 atoms of Na. Okay, so what I'm going to do is use this conversion factor to convert. I'm going to change my volume to 0.5 liters, and we'll start with that. So 0.5 liters, always start with the thing that only has 1 unit, like just liters. Put that over 1. Then I'm going to multiply by my conversion factor, and I can leave it as it is, moles over 1 liter. And then I want to convert to molecules. So this would be your first step. Let me change to red. If you wanted, you could put an equal sign as before. And now I'm trying to count how many things I have. So Avogadro's number is what you use to count. For every 1 mole, you have 6.02 times 10 to the 23rd. And in this case, sodium carbonate is a molecule, so you must convert to molecules first. Okay? And then this problem actually has 3 steps, which is pretty intense. So if you look for every 1 molecule of sodium carbonate, you have 2 sodium atoms. So I'm going to put 2 atoms. That will let me convert molecules. If you see moles cancel and liters cancel. That's the 3rd step of the problem. And oh, I forgot to label a second. So you could have that as 3 separate problems. If you do all that math through, you're going to get 3.0 times 10 to the 23rd atoms of Na. And that is your final answer. So if you can get through those by yourself without me, I think you'll be pretty good to go for this stuff. Have a good one.